And then coin ownership distribution, right? So depending on how much power and staked capital you have on the network, especially these pools, you're going to have more coins and more rewards and more potential political say. So first, we're going to look at the node distribution. So this doesn't break down by hosting providers, but you can see hosting is 63.9%. This is taken from ethernodes.org. You can go there right now and you can look up these charts in real time. And so right now, most people aren't solo staking. Most people are staking with some type of provider that's staking with a hosting provider. And so what this actually looks like, this was the chart that made the tweet blow up. And actually the number of nodes on Amazon have increased since my tweet in August. And so hosting distribution. So Amazon, we still have quite a few on Hertzner. And so, if, Amazon cannot process blocks, something happens to all those nodes, there's such a super majority that would impact everybody staking on that infrastructure. And you might not be aware, because you're staking through a service provider, that you would be in that slashing pool. So it's definitely something to consider. And then just the performance, right, of the network. We're familiar with, in the proof of work world, when there was high transaction volume, things would get expensive, transactions would get dropped. It was a really unpleasant experience. This can still happen if there's some type of outage with Amazon. It can make the user experience and actually doing transactions very poor, even if the entire network doesn't go down itself. So then we have depositors by category. So you can see it's staking pools is the largest, and then exchanges. So the combined staking pool plus exchanges really makes up the majority of what's being deposited on the network, and that has many other implications. Oh, I went back. And so in September, 13.5 million ETH were staked, so a lot of money. And more than 60% of the ETH was sitting with Lido, Coinbase, Kraken, and Binance. So all of these entities have a much higher likelihood of being assigned to produce blocks of transactions because they have more staked ETH. And so some of the concerns that were brought up when this happened or when this was realized is obviously they're getting more of the rewards. They're earning most of the money coming from the network. And there's a lot of discussion around censoring transactions around the network. A lot of them use MEV Boost. If you're aware of what happened with the OFAC sanctions and Tornado Cash, these entities producing blocks were able to censor transactions that are based on OFAC sanctions, and so allowing unequal access and making Ethereum not a neutral network. And so, more importantly, and this is happening right now, you can see what's going on between Lido and others, is that they're defining the rules on block formation and what type of blocks get created. Once again, so they can say, like, these type of transactions can be included in blocks, these types of transactions should not be included in blocks. So they're going to be able to set the rules of how things work in Ethereum proof of stake. And then other staking entities, if they don't follow these rules, could be penalized. So it's really important that not, one group of entities producing blocks are creating the rules for the entire network. And so this is from Martin Kopelman. If you don't follow him, I highly suggest it. Founder of Gnosis and OG Ethereum person, and I believe now working on Gnosis Chain. He has a lot of great material around kind of like watching what's happening since the merge. A lot of people agreed that it's not great that, Lido and Coinbase are producing all the blocks. And so another type of, decentralization, or in this case, diversity, that's really important to blockchain networks is client diversity. And so right now you can see Geth has 77% of the consensus clients, so what people are running. And so, once again, Peter, he's another good person to follow if you're more curious about what's happening. It is similar to if all the nodes are being hosted in one place or there's a lot in a pool. If something happens to the consensus client later, people will also get slashed if you're running that same consensus client. And so, I read an article that it's not great to have one consensus client. It's better to have a majority. In Ethereum purposely, a diversity, had multiple clients running, but it's actually worse to have multiple clients and one in a supermajority than it is to have one consensus client. So it is something people are working on, and there are other clients that you can run. So you can see once again, there are ways to monitor it. You can find it, but it's still, Geth is in the lead, and it's a big concern for many people that are worried about the health of the network. So really quickly, just a couple examples. So there are risks of infrastructure, hosting, pool, and client centralization. So in any of these groups, if 1/3 of the validators, or like slightly more than 1/3, run into an issue, the network will start slashing that group. So anybody that's in that group. And why? So consensus needs 2/3 of validator agreement. And so if you're in a group that's more than 1/3 of the nodes running into issues, that group gets slashed until the amount of ETH inside that group is below 1/3 of the total stake. So you just keep, and when we say slash, it means that ETH is being taken from you. And so if you're in that group, you're going to just kind of bleed ETH until you're less than 1/3. And so right now, the Ethereum network has 3 major attack vectors within clients: Prism, Lighthouse, or Geth. And so if something goes wrong in those, that whole group starts getting slashed. And like really quickly, once again, let's say Amazon has an outage issue or decides to censor, and they have 53% of the hosting nodes right now. These nodes will all start getting slashed until the value is less than 1/3. And so, going from 53% below to 33% before the slashing would end. So anyone hosted on Amazon would suffer as a part of that. And so you as an individual don't have control because you're a part of this potential slashing group. And also, as I mentioned, you may have no idea where your nodes are being hosted if you're going through some other type of service provider. And right, once again, 80%, I think it was about 77, use the Geth client. If something happens with the Geth client and they make a mistake on the client, 80% of the network would be slashed. And so like the network cannot finalize in these cases. It can't come to finality, which is important for updating the state of the network. And the penalties are much more severe for those using Geth because of the inactivity leak. So everyone using Geth is impacted. And so their stake is burned or slashed until the beacon chain can finalize again. And this is just a repeat bullet. So whether it's hosting, whether it's pool, because the pool is hosting there, or the pool in general, or whether it's at the client consensus level, there's a lot of risk with centralization and you being penalized as a validator. And so like to what degree does decentralization matter in these networks? There's like a big debate on that. And like every blockchain protocol has their own version of how decentralized they want to be. And there was a talk by Tech from Gnosis Chain, and he was mentioning Gnosis Chain wants to be one of the most decentralized networks, and that there tends to be a bit of a tragedy of the commons when it comes to decentralization, or it's like this creeping phenomenon where people don't actually care about it until it's too late. So until this large group starts getting slashed. So not something that matters because the performance of the network is running fine, and most users, probably especially ones not at a technical developer conference, are not that worried about decentralization. They're worried about, being able to successfully use their app. And right, the Ethereum network goal is to be a credibly neutral, resilient, scalable, and global settlement layer. And the Ethereum validator goal you probably have, or if you're staking somewhere else, is to be a performant validator, earn rewards, and avoid penalties. And so, right, as we've been, as I mentioned today, the Ethereum network actually encourages decentralization. Less penalties for running your own validator node, for running your own individual client, for not hosting or going through a pool. And in general, the Ethereum community is working across all these points of centralization to ways to decentralize these different aspects. So the node infrastructure layer, the pools, the client diversity, the geographic distribution, and block construction. So these are things, and coin distribution. This is not a presentation that the Ethereum ecosystem is like for the first time hearing. They're very aware of all these things and working very hard to improve the resilience, decentralization, and even different staking providers are trying to distribute where they run their nodes. Okay, so now I'm going to pass it to Shane from Decentralized Authority to talk about different node running options.
Right. So, having an understanding now of kind of the landscape within Ethereum and the requirements for being a node runner, what options are there for actually running your own nodes? So actually, let me get the clicker from you. Okay. Oh, well, let's see here. There you go. So, node runner landscape. Advanced users, the world is their oyster because they can, there are going to be some skills required if you're an advanced user. We're talking about you understand Linux administration, you understand networking, scripting, Docker. These are all skills that you have, and so because of that, you have numerous resources for learning about which nodes you want to run, which clients you want to run, how you want to run them. There's a lot of documentation with every single client about becoming an Ethereum validator with them. There's no limitation on the location of where you want to host your nodes, and there's no limitation on the client choice because you can take anything and run with it because you have the skills to be able to do that. You can also create custom tooling. So you're a developer, you're competent on the node running side. You can also develop your own tooling for monitoring, for notifications, things of that nature. So if you're an advanced user, there's a lot of options for you out there. Now the entry-level users. So these are the folks that don't have all the skills mentioned above. Well, the good news is there are 3 different GUI-based software options. So this significantly streamlines the level of skill that you need in order to run a validator. You might be limited on the location on where you can host that validator. We'll get into some of that, but with an entry node or with an entry-level user, you're much more likely to probably want to run it at home. You also might be limited on the client choice because if you're using a software platform, you're limited to whatever software or whatever clients that software has available to you. But the good news is minimal skill is required. Mostly it's copy and paste with anything that, any commands that you have to do, it's just copy and paste. So there are really good options out there. So that's what I want to talk about, entry level. So this is Ethereum, I believe it's pronounced. This is a very cool option. I'm categorizing it as a remote server controller. So what you do is you can actually install their application on, it's cross-platform too, so Windows, Mac, Linux. You install it on your computer, and then you can connect it to a remote server. They have a very simple tutorial on setting up a remote server with different cloud providers. But really what happens is after you just sign up for a server, you can actually point their application to that server, and then the application takes care of everything. And it actually does it through a really cool technology called Ansible. So it basically is able to send commands to the server to set it up perfectly for you. And so with this kind of setup, skill-wise, you can be a novice. They have great tutorials. It's very simple to set up. Time-wise, you're looking at maybe about an hour or less. If you're following their tutorials, it can be done very efficiently. Notable features. It's got a complete GUI user experience. Everything's in-house. They're not using third parties. They built everything internal. It's really a great suite in that sense. You have a lot of location freedom. Because this is a remote node controller, you can host your node really anywhere on any kind of provider. And so you really have a lot of location freedom. You have extensive client options. They do a great job with giving you tons of different client options. So you could actually take a look at those charts that Maggie was showing on, okay, which ones are over that 33%. And you most likely don't want to be in that group because if something happens, so if, say you're with Prism and something happens to the Prism client, there's a mistake in an update, what have you, what happens is if they're over 1/3, that whole group is going to start getting slashed. So you want to be in a smaller client group, and that's actually what's brilliant about how Ethereum is designed, is they want client diversity so that you don't have the whole network hinging on one client. Another platform, Avado. this is a really cool platform. It's different than the other one because this is a hardware platform. So this is something where you have to actually buy their hardware in order to use their software. So it's kind of like that complete package, which is great for some users where they just want to buy it and have a real easy kind of point-and-click setup. But you know, you do need to buy their hardware. You can't just use it on your own hardware, and you also don't have hardware choice. But skill level-wise, novice, very easy to use. We're talking an hour, maybe a little bit more to set up. It's a little there's a few more steps in it, but it's still a great user experience. Some notable features is there's no OS configuration because you're buying the hardware. You don't have to set up the OS. It's a full package in that way. They also have a really impressive app store where you can deploy nodes from other blockchains or other clients, and it's really cool. For validation, though, from my understanding, I think there's a limitation on what clients they currently offer for validators. So you might be limited in your client choice with a platform like Avado until they add more clients that can be used as a validator. Probably the most popular that people know of is DAppNode. So DAppNode, it's a server platform. So this is one where if you have your own server, you can set it up and run it. Skill level wise, I give this a moderate, and the reason I give it a moderate is because there's a lot of options. So for some users, having that amount of options could actually be something that is very intimidating. And so, but there are some great tutorials that can take people through setting everything up for a DAppNode. It takes a little bit more time because there are more options. There's a few more things you need to set up. But their approach is really cool. So notable features-wise, they have this modular approach. So you can choose different monitoring tools that you want to use with your node, and they have a really cool way of just being able to kind of create this way of just deploying different packages, as they call them, deploying different packages that are kind of part of your validator suite, if you will. So there's a lot of customization there. They have a very simplified OS installer, so you can actually install it from a Ubuntu image that they provide, and it just streamlines the whole process, so there's less that people have to do. They have a very impressive app store as well. Far beyond actually nodes, they also allow you to host your own dApps and things of that nature, and so there's a lot of options, especially or in the Ethereum ecosystem, there's a lot of options that you can do with DAppNode, so a very impressive platform. And it's advanced user friendly. So advanced users can actually do a lot of modifying. There's a lot of kind of, there's kind of this like tweaking community inside of DAppNode where people are able to set things up in a certain way to achieve certain goals. And so that's a really cool advantage to being in kind of this platform is there's places you can go far beyond whatever's in the just in the GUI itself. So, node software is the best way to decentralize, and that is my argument. And the reason I'm saying that is because node software can encourage anyone to run validators from home. You don't have to use a cloud platform if you can easily and simply run validator nodes at home. It ensures that updates and best practices are being applied. So if say someone wants to run a Ethereum validator, but they don't have software options, they're going to have to go through these very complex tutorials on trying to copy and paste all these commands into terminal in order to try to get it all working, but they don't know exactly if everything's working properly. They don't really understand how everything's working. That's actually where node software can come in because it can standardize how things operate and ensure that best practices are being deployed when you deploy a node. When you deploy a validator. It also simplifies client adoption. Ultimately, if you have options inside of these software platforms, you can choose, which clients you want to use. Ultimately, that's where software can go, and software can make it just really easy for people to pick their clients and pick the small ones and the unused ones. So what are some challenges to developing Node software? If that's kind of one of the key ways that we can really encourage people to run at home, what are some of the challenges? Well, it requires full stack development skills. So we're talking back end to front end. So you have to be really familiar with the whole back end. You have to be able to deploy nodes, understand Docker, or if you're just deploying them directly onto the OS, there's a lot that you have to figure out on that side. Plus, you have to worry about the front end. So you really, the software has to be really a full stack software in order to really be able to meet all the requirements to be a good running Node software. We're also talking about you have to have a deep understanding of Node running itself. You have to understand the best practices. You have to understand what your software needs to look for, X, Y, Z. While also, right brain, left brain. You also have to think about the user, the creative side of figuring out user experience. What will engage users? What will make them want to use your software? So you really have to have a deep understanding on both sides of that. Minimal node tooling is there's minimal node tooling. That's kind of a weird sentence, but minimal tooling is out there for people who are wanting to develop Node software. That's just kind of the reality of where we're at right now. So if someone went, hey, I want to develop Node software, you're kind of starting from scratch. You've got to develop everything on your own with all this understanding. And so those are kind of the challenges that we see right now in getting more Node software out to more people. But I didn't really give an introduction to decentralized authority. What we're doing is we're developing software, and specifically Node software. And so I wanted to talk a little bit about how we can see the Node landscape changing with Node software with tools like Node Launcher, which is a TypeScript node deployment engine. So Node Launcher is an open source node deployment engine written in TypeScript that enables the easy creation of node development applications. So if someone wants to create an application that is for running nodes, what Node Launcher does is it allows them to start developing that application without needing to understand the back end because it's a full deployment engine. It will deploy the nodes in the proper way using APIs. The features, nodes can be deployed and controlled through standard APIs. You don't have to know how to deploy something on Docker, all the proper Docker configs, all this stuff. You just simply need to be able to understand a TypeScript API, which TypeScript is amazing for application development, and you can be off to the races to develop your own Node software. You are able to programmatically deploy nodes and upgrade them to validators. So what does programmatically mean here? In this case, like with the other platforms that we showed, there's manual steps that you have to take in the process. You either have to copy a file over here, you have to save this, you have to do, so there's, in the process of deploying a node with those other software platforms, there are certain processes that require human intervention. Programmatically means you're able to do this entirely through programs. So you can actually have all the elements that would require a human to copy this over here, to do this over here. You can have that all done in a programmatic way. So it creates a much more seamless user experience. And you have way more control over the nodes and how they're configured because it's all programmatically designed. You have seamless client updates with Node Launcher. If there's a new client, and this actually ties in with this point down here, we have a client test suite. So I'll kind of tackle these in a scenario that's happened recently where we have a client test suite where when a new client comes out, we're able to test it against this library to make sure that nothing breaks inside of this library, which Node applications can use. Well, earlier this year, the Geth nodes came out with a new version that actually sunset a configuration. And it wasn't like widely used, but it was a configuration in there, but it wasn't in the release notes. So we actually put it through our test suite, and we realized we were getting all these red flags. We reached out to them, like, oh yeah, they were sunsetting this, but it wasn't in the release notes. So there's elements to where even on the client side, they can just make an update to something, not realizing that other people might be using different configurations that would affect that. This is where Node Launcher comes in. By this can actually eliminate. So eliminate that attack vector, or not necessarily attack vector, but that slash event, where if there's a problem with geth and there's a feature that people are requiring, and that's suddenly taken away and it's not realized how widely it's used, Node Launcher would catch that before the upgrade happens. So that's the advantage of thinking holistically about the back end of running nodes. So this is an example of what a simple API could look like. So for application developers, this is what you need to allow your application to deploy a Ethereum validator. For the developers out there, this is simple. This is super simple. You're not having to touch Docker. You're not having to touch anything on the system. The library itself is doing everything for you in the back end with best practices, and this is all you have to add to your application. So, Node Launcher, is it in use? Yes, it is. Node Launcher has been well battle tested through Node Pilot. Node Pilot is a consumer-facing node management software that we've been developing. We're currently in beta. We're hoping to come out with version 1 Q1 of next year and make it fully open source. So far, thousands of nodes and validators have been actually launched through Node Pilot. So it's been heavily used. It started off primarily in another network, Pocket Network, which actually serves RPC calls to Ethereum applications. So it's a really cool synergy there. But the interesting thing about Node Pilot is the fact that Node Pilot is 62% CSS, 25% SCSS, and 13% JavaScript. So we're talking about like a web application, but yet it's able to run and deploy nodes and create a user interface and a user experience that allows more people to have access to node running, and it's just a simple application. Ultimately, with Node Launcher, any developer can start creating node deployment applications like Node Pilot. We want to open up this space so that there's innovation happening on the user side of node software, because we want more and more users to be attracted to the space, and more users are going to be attracted to the space when we have these kind of software that meet different users with where they're at or the features that they're looking for. We can see that innovation start to grow with tools like Node Launcher. And so we've actually begun testing Node Launcher with Ethereum. Node Launcher, we successfully launched a testnet Ethereum validator last week using entirely only Node Launcher. So we're very excited about that. We still have some refactoring, we were in the middle of refactoring. I was talking to the dev yesterday, and he's like, well, the version right now has some bugs because I was refactoring and broke it. So right now what we currently have on our GitHub is broken, but that's the beauty of what we're doing. Is we're building it out, and then once we're ready to make it production ready, it's in right now it's in its own dedicated branch. But once we push it to master, then anyone could actually use Node Launcher to create validators for Ethereum. We want to add multiple clients by the end of the year. Development progress can be followed on our GitHub, which is Node Launcher decentralized authority, or our decentralized authority GitHub. And we hope to see developers use this tool or use tools like Node Launcher to create next generation node software, where it's super user focused, super feature rich, so that it can attract more people to want to, if they're considering, hey, should I put my stake in a staking service, or should I run it on my own? It's just so simple to run on your own, and there's so many options for running on your own that you don't even need to consider giving your keys and putting your trust in someone else. So kind of in conclusion then, with everything that Maggie talked about, and then what I'm kind of closing here with, in conclusion, Ethereum is designed for optimal decentralization. It's really designed to push folks to decentralization by having those large slashing events, where if you're part of too large of a group, using a certain client or on a certain cloud provider, you'll start getting slashed if there's an issue there. It really incentivizes the run-at-home decentralized kind of ecosystem. Validators can protect themselves by from potentially large losses by avoiding oversaturated cloud providers. AWS, 53%. It's starting to get to a point where it's a risk if you deploy on AWS, simply because if something happens there, even if it just goes offline, they have a DNS error, and something goes offline, which happened last year. They had entire data centers going down because an admin accidentally pushed a patch to their DNS that broke everything. Those kind of simple things could actually affect the entire network. So it's becoming a risk to be on these large platforms. And then use clients with less utilization in the network itself. Right now, if you're using Prism or Lighthouse, you're in that 40% range. So if something were to happen to either of those clients, you could potentially see large losses. But the good news is there are great options for entry-level users to participate in the Ethereum validation. I definitely encourage you to go look at those options. They are listed on ethereum.org when it says stake Ethereum, and they talk about different options. All these options are there because they were open source, all three that I mentioned. They're really great options. There's no reason to not run your own Ethereum node today. But then kind of looking to the future, we are very excited. We're very bullish on where node software can go. And the kind of user experience that can become standard for node software. And we're excited to be working on our side on the tooling side, Web3 Cloud's working on the infrastructure and hardware side. So really the future is super bright with Ethereum validation. We want to encourage everyone to run their own Ethereum nodes on their own. So that's thanks for joining us. I think are we doing like a Q&A? Because we have like 12 minutes. Do we have 12 minutes? Okay. Yeah. If folks have any questions about any of this, let us know. Yes. Yep. Yeah. So I'm not a developer. So how exactly Node Launcher's Node Launcher is dealing with secrets? Yes. What we do have is the RPC password for those nodes are actually being stored in memory. So there are elements that are being stored in memory with Node Launcher, and so they're not in plain text. Now we're still developing Ethereum and figuring out how are we going to handle all the handle everything, handle all the secrets, but we're building into Node Launcher ways to protect from having plain text anything on your server, because we feel like that's where Node software should go, to where there's a lot of security around how what's being stored on your server and how it's being stored. And so utilizing something like memory is one way that you can put the password inside the memory and not have it be sitting on your server itself, so the RPC password. But you can actually check out the GitHub as a developer, and you could figure out how a lot of that's working. So I'm not a developer, so I can't get into all the specifics about it, but that's kind of a general understanding of what we're building towards.
Hey, thank you very much. This was really useful. So 2 questions. One, the only thing stopping me from running a node at home, like locally, is that I don't have a good connection. Like, I live in a very remote area. So perhaps a little, update on the best setup for that. And the second question is, if I don't have 32 ETH and I want to run something at home, is there an option?
So to address your first one, if you have bad internet, so how penalties work in Ethereum for being lazy, right? This is either you're offline or you're not keeping up or something of that nature. That's considered a penalty. So what a penalty can be is it can either be a reduce in rewards that you receive, or it could actually be where what you would have gotten if you were operating optimally is deducted. So you're slashed very small amounts. So say you're, so in a day, maybe your internet goes out for 30 minutes or something like that. You're deducted what profit you would have made in that 30 minutes. So you lose out on those 30 minutes of reward, but then it essentially is almost like you lost an hour, right, of rewards because it's, it's deducted, right? So that's where you can kind of gauge, you might not be as profitable even if you're in an area where your internet kind of cuts in and out or something like that. You just need to kind of gauge what that might look like. And maybe it's worth running a validator on one of the test networks to kind of see what the performance is like, to see, okay, would this be profitable? Would this be worth going? But then there are, solutions, and I'll mention Web3 Cloud, that are putting a lot of work into getting servers and getting hardware into different parts of the world, into different regions that are kind of outside of the cloud gig, so that if you really do have bad internet, there will be options where you can deploy to hardware providers that aren't tied to that same like cloud cluster that we were talking about earlier. Was that both of your questions? Oh, and if you don't have 32 ETH. So if you don't have your 32 ETH, that's you can still run nodes. You can still run nodes. You won't get any rewards for them. But you can, there are other staking pooling options, like Rocket Pool is a good one.
Also, if you have friends that trust you, then maybe you can aggregate some. People do aggregate ETH amongst groups of friends who may not have enough ETH, and then adding in a point of trust, but it's an option.
Yes, sir. That would be the case, I would say, if Node software wasn't being taken seriously. So with Node software, people could minimize a lot of cost and also minimize certain risks by just running it at home. So while yes, you could have large providers like AWS, and it really comes down to 6 providers, as you mentioned, right? 6 providers. Sure, you can go that way and spend money each month, or you can have an old laptop running where you're keeping all the rewards and you don't have that overhead, and it's that simple to run. So I think you're right in terms of just what tends to happen in these kind of ecosystems, but I think because of the way that Ethereum has approached proof of stake, where they intentionally put in mechanisms to incentivize more and more decentralization, I think the market will match that, right? And I believe there are going to be a lot of options for Node software in the future. There's already 3 great ones out there. We're building one ourselves, and we're building tools that allow more people to build them. So I think the future is really bright with that. So that's my thought.
May I ask if Node launcher is capable to integrate the DBT node deployment?
I'm sorry, the what node department?
DBT, distributed validator technology, something like.
It's what? I'm not particularly familiar. What Node Launcher is, in a really simple term, is it's actually like an API engine for Docker. So it allows you to put TypeScript commands, and then it automatically converts it into what would be either sent to Docker or sent to a container inside of Docker. So because of that, yes, like the Node Launcher could actually be used for any container system. We're focused on nodes because that's our focus, but you could actually use Node Launcher as basically a JavaScript API to build any kind of container-based node infrastructure or container-based application or management. So it's very adaptable. It can apply to any parts of the node. any parts of any container. One of the things we're building right now is the ability to deploy multiple containers. So there's some like Polygon that require multiple containers, right, in order to run their node. It's actually multiple nodes. So we're building in that ability to have all those nodes all orchestrated and working together without needing to do it manually, because it's all handled through the engine itself.
Thank you.
So there are, so on ethereum.org, there's all that information, so I definitely check it out there. From what I remember from looking at it last night, is they recommend kind of on the low side, or on the recommended side, was a i7 4470, which is like a 15-year-old processor. So, so yeah, an i7 from like 15 years ago or something. So anyways, yeah, Ethereum is very well equipped for minimal hardware requirements, unlike a lot of other networks out there.
And then that one you said that's a remote server, does that change the hardware requirements?
No, you just, on the server itself, needs to have those requirements, which are very minimal. And then their application, I believe, can just run on any computer that's running either Windows, Linux, or Apple, or Mac. So, got 2 minutes. Yeah.
I was speaking to Devcon, and they were telling me they had this additional way to increase your profit on the yield by earning like the big clients with MEV.
MEV. Yep.
So does your system have something similar like that to acquire or to play around with that?
Absolutely. Like, so we don't have it integrated right now. I was actually just talking to our devs yesterday about it. We don't have it integrated now, but it's literally a service that you run alongside your Ethereum validation. So it's a container. Yes, we can absolutely, and then that's what Node Launcher does. Makes running containers super easy and able to do it in a programmatic way to where it all automatically connects. So yes, MEV is absolutely possible.
Hey, sorry.
Yes.
Thank you both for the talk. I've been running with my own hardware. Wanted to get like a recommendation on like, well, the setup was pretty complicated. Like you mentioned, like the resources from the Ethereum Foundation, then they point to a random guy's Medium post and another random guy's Medium post, which is not updated, or how do I know if it's updated or not? And good luck if you want to run any that are not like Geth and like a typical combination of Prism or Lighthouse, right? Like the documentation for anything that's not like the main ones are non-existent. So first question, is there a source of truth in documentation which I can follow, like to set up my own hardware with the Ubuntu server and like go through it? I mean, I'm no magician or anything, but like I can.
Yeah, I would say ETH.org is the best place. The official Ethereum documentation from the Ethereum Foundation is probably the best. But also, it also depends on the client that you're using. So different clients do have different hardware requirements. From my understanding, each client in their documentations specifically state what their hardware requirements are. So I would actually look at the documentation for the client and see what the requirements are for that. Now, the one thing you do need to be aware of is, as Maggie mentioned, you have to run a execution client, you have to run a beacon client, or consensus client, and you have to run a validator, which is really just a consensus client that's only job is to be a validator. So you have to run 3 different clients. So even though maybe the one client has certain hardware requirements, you have to also look at what other clients are going to be using, and then you have to, bring it all together. So I would say go to the client's documentation, figure out what each one is after you decide what you want your makeup to be, and use the information that Maggie gave you in terms of the usage on where how utilized certain clients are to make your decision.
Cool. And just one, I don't want to put you on a tough spot, right? But for the sake of decentralization, is it, am I better off like going into, well, I don't think I could go to Dabnode or Avado because I'm running my own hardware, but like using something like Ethereum, or am I like exposing myself to any risks if I go like install everything myself?
Well, for one, you can use DAppNode on your own hardware. So that Avado is the only one where you have to have their hardware. So you could actually on your own server use DAppNode. But I can't really speak to actually the Ethereum.org. They actually do give in talking about these different options. They do list out different features or different elements to them, where like some of them have been audited, right? Some haven't, right? So you could actually potentially use that as a way to gauge. But you know, most of the time with something like with stuff like both DAppNode and Ethereum, you know, those aren't things that are exposed to the public, right? So the application is just sitting on your computer, and then that's connected. So if your computer were to be hacked, is how Ethereum would be hacked. So the app would have to be hacked from being on your computer to be hacked. So there's going to be risk no matter what options you use. But yeah, there is some information on the Ethereum network or Ethereum.org about that.
Great. Shane, thank you so much.
Thank you, everyone, for being here so early in the morning. As I mentioned on the last day of Devcon, you can follow us to stay up to date on what's going on with Node Launcher. And if you're a protocol looking for Node software or even hardware infrastructure and want to decentralize, you should contact us because that's what we care about, what we like to do. So thank you so much.
Hey guys, if you're waiting for the advanced, the Seaport one, we're just looking for the speaker. Once he's here, we'll start. Right? Hey guys, there seems to be some sort of confusion with the speaker. I think he gave the same talk 2 days ago, so he might not be coming. I'm just confirming that. So if you have anywhere else to be, you can leave. Otherwise, just wait around for like 5 more minutes until we confirm. Cool? Thank you. Sorry for the confusion. Hey guys, I think it's not happening. The speaker is not going to show up, so yep, feel free to stay around or like do your own thing. Cool. But what? You can have impromptu talks if you want. Alright. Thank you. Yep. Sorry for the confusion.
1, 2, 3. Okay. Check. Check. Yeah, having some technical difficulty, but we'll start soon.
a couple more minutes. Yeah. Yeah, I mean, I don't know how distracting the green thing is going to be when we show terminal stuff. Maybe a little bit. Yeah, for the demo it's going to be bad, I think. So maybe yes, that's okay. That looks good, okay. Okay, hello everyone. Last day of Devcon. Thanks you a lot for coming, and yeah, we hope this is like a fun workshop for everyone, and we can actually get to see how this technology works, and you might be able to like run it on your own, hopefully by the end. Yeah, do you want to introduce yourselves? Yeah.
Yeah, sure. Hi, my name is Jennifer. I'm a software engineer at Chorus One. Chorus One is a staking provider. Like we run validators on lots of different networks actually. But of course, the coolest one being Ethereum, and this is what we're going to talk about today. Gabriela?
Yeah, my name is Gabriela. I part of like the research team at Chorus One. I focus on Ethereum mainly, and yeah, definitely the coolest chain, the one that matters. So the title of this is Spin It Up Validator on Testnet, and yeah, the way I think we wanted to structure this is basically in the beginning I'm going to be giving you like an essentials outlines of like the different parts that we're going to be looking at when we will move to the second part, which is the demo. When Jennifer is going to actually demonstrate how to spin up this validator. And well, then I think you'll get the time to do it yourselves with the repo that we're going to be sharing with you. The information on like the Wi-Fi is over there if you need it. And yeah, then maybe this kind of like we wanted to co-create it with you. We can continue into like the steps on the validator, so exiting the validator, or we want to do like more bonus things that we think could be fun, like going more into like the block explorers for the validator that you created, and maybe like even understanding a little bit more like in Etherscan maybe like the different parts that we mentioned during the essential like talk that I'm going to give. So yeah.
I think one thing I'd like to mention, like, feel free to like just interrupt us, ask any questions. This is your workshop, and this is why we also leave it kind of like very flexible for you, what kind of like exercises you want to do. And then we'll see who's interested in exiting a validator. We have some keys that you can use that we've already deposited. And they will only be available during this workshop. So if you want to play around, do it during the workshop. After that, they won't be available anymore.
All of these, of course, powered by Chorus One, who gave us these keys, our company. So yeah, I think we're ready. Yeah, let's go into like the essential like talk that I want to give.
Do we? Let's give some context actually.
Oh,
maybe
right,
about
right,
how this workshop actually came about. Namely, the past few months we were like working really hard on an API to automatically spin up validators. I'm super proud that we're like this week we like released it, so I can publicly talk about it. Kind of my baby. So basically, obviously, before you automate something, you have to do it all like manually. So I found myself running like lots of Docker containers and like running validators just to test it. And with Opus API, you can actually just call our API and it will spin up a validator automatically for you.
Yeah, very cool. And yeah, we have like announcements on our Twitter and everything if you want to read more about it. But yeah, I think you're here to do the practical part, less healing. So okay, let's go to this. And yeah, I wanted to start with like kind of like a big picture look into like the Ethereum network. And well, Vitalik gave like this very good talk during the opening ceremony, but I guess I wanted to take a little bit from that and also make it like more pertinent to like the topic of staking and validators and what they do inside like the network that we are creating here, no? So yeah, this is again a quote by Vitalik, and I'm not going to read everything to you, but this is like a cool, I think, look into what is blockchain, and the different parts that we are going to be seeing today are mentioned there. But I guess one of the most important parts to, I guess, pick out of this definition is when it says like, carries very strong crypto-economically secure guarantee. And well, crypto-economically is basically a made-up word that we have here at Crypto. But yeah, it has a lot of meaning, specifically when it comes to like the security of the Ethereum network. It has two parts: the crypto, which makes you think of math, and then like the economic part, which makes you think of money. And it's like math and money has a lot to do with like the things we do here, but yeah, and specifically like the role of validators here in the network. So that is essentially like the idea that we have behind these blockchains. And there's like quite a few of very like interesting things that they can do. For example, for me, I do find that like the guarantees that they have to continue running even if people like are not interested in them, that they are basically like infinite and they continue even like beyond, hopefully beyond the ages of everyone here present. They have like very high availability, like uptime and everything that we try to keep here on the network. And basically, all of these blockchains that we kind of hear about, they're part of this called, they're part of this thing called like consensus protocols, right? And when we think about consensus, what we're basically talking about is trying to keep like a huge number of different computers in sync, even in front of like all of the challenges that you could find to keep like a number of distributed computers like always in sync, which could be like network outages or even like denial of service like attacks. We know of those here in Ethereum, yes. But basically, when we try to think about like this definition, we are basically conflating like two different things, or two things that are kind of conceptually different. Especially when it comes to like smart contract platforms like Ethereum. And for example, when you're running like an Ethereum full node, and yeah, by the end of this workshop, I hope everyone here is like capable of doing that, then it is true that you're running like a consensus protocol. So on that side, you're working hard, like connecting to other nodes and trying to bring like all of them in sync, like I said. But at the same time, what you are staying in sync on is like this set of instructions. And these instructions are in themselves like updates to the state of the machine that we are running, right? And these instructions could be like as simple as like transferring money to one side to the other. Ethereum is good at that, but also much more complex things. And well, I think this talk would have been better at the beginning of Devcon, but we've seen like so many of those applications during the week, all the things that can be done, no? So if you're running like that full node in Ethereum, then you're also like responsible for like the compute and the computation of all these instructions that we call on consensus of. And those are two very distinct responsibilities that are worth like separating. And when we see that, well, what I'm talking about is obviously like the separation between what we call like the execution layer and the consensus layer in the protocol, no? That is like kind of like the main architecture behind the nodes that you'll be developing. So we want to dive just a tiny bit deeper into these two things. On one side, well, you can see the architecture there. But yeah, on one side we have the consensus and this consensus mechanism. So you might be wondering, like, okay, how does Ethereum keep like this X number of validators in sync? And well, nowadays, or by the time like I was preparing this presentation, then that number was like X correspondent to 441,747 active validators. But there is a world, right, where there could be like millions of these, or we hope that there's millions of nodes running. And we can actually like cap the amount of nodes that the Ethereum network can handle, because it is a function on like the total supply of Ethereum that is currently like on the network. But yeah, to understand like a little bit more about the relationship between like supply and ETH, then I would recommend like a talk that was given here called Ultrasound Money. Won't go very deep into that, but yeah, to go back into our topic, Ethereum today uses something that is called the Gasper consensus algorithm. The too long didn't read is that it's not really like a single algorithm that controls the network. It's like two different and very complex algorithms, one bringing like the block finality and the other bringing like a fork choice. And I do love talking about this, so I will go a little bit deeper. I hope I don't lose you. Let's see. Casper, FFG, is the name of the finality algorithm. So basically, and yeah, I want to relate it more to like the validating process. So during the block proposing process, like basically randomly, like one of the validators of the whole set of active validators that I mentioned is selected from the pool. However, what is expected is that the network will grow like in a single blockchain, one block at a time, one by one. But sometimes the network, like I said, could fall out of sync and produce or broadcast, or two validators might broadcast like two valid blocks that could be potentially added to the network. And when that happens, that creates something that is called a decision or like a fork. And even like small forks are very like existential threats to like the protocol or different distributed systems. Because there should always be like one true blockchain or one canonical blockchain. So Casper, the idea, and not going into details, is to like give certainty to like this one true blockchain. And the fork choice would be like, it's called LMD Ghost, helps to complement this Casper protocol. And like I said, most of the time it grows one by one, but sometimes like the choice appears, okay, which one of these fork choices should we choose? So this is like a function that takes like all the different paths that are in the chain and spits out like the one canonical chain that is going to be Ethereum. And together, like both of these things try to keep like the network in sync at all times. I think that's a pretty cool description. Going into like the execution part, like I mentioned, basically Ethereum is definitely more interested in like being a consensus protocol, and the EVM is interesting, but in my opinion is something that can be changed in the protocol. But yeah, Ethereum exists in a network that has like thousands of computers, And each of them is currently running like a local version of the Ethereum virtual machine. And basically the EVM is like the place where all of this decentralized computation happens, all the smart contracts and all the transactions that we know. And that is a place where all of those contracts live. And this is the same environment. Like, it doesn't matter what kind of computer you have or what kind of client you're running. It basically is like the same environment all across the network. Within the EVM, there lives like a number of entities that are called accounts and like contracts, objects, and the ETH, which fuels like everything within the network. And basically, what the EVM has to do is basically follow like a set of rules. And the main rules there are that everything should be recorded in blocks, everything that happens inside the EVM, and should be added to like the public blockchain. Anything recorded in the blockchain cannot be undone, and all objects should have like an owner, and they cannot be altered without the permission of the owner. This is very basic. Some of these things are changed depending on like different applications, and different like things that are going in the protocol, but this is like the basic rules, I think. Going pretty quickly in this, another interesting thing are like the different clients. So today in the workshop, we'll be using two, I guess, minority clients. I mean, it's difficult to still say that Lighthouse is minority, but yeah, we'll be using that at some points. And also like Teku for what you've been doing, while you've been doing. And also in the execution side, we'll be using Besu, which, yeah, I think we could say is pretty minority. And yeah, like we said, we have like this execution part and this consensus part, and we have execution clients and consensus clients. The execution clients will listen to the different transactions, they change the state of the EVM, and they hold like the current copy of, well, the state. And the consensus client, well, they keep all the machines in sync so that the proof of stake, well, consensus algorithm can work, no? And well, Ethereum having like different implementations is actually like a great asset. I think we all know it. And yeah, the important part there is keeping like each of these implementations under like a security threshold so that the network can stay online at all times. Yeah, I think we're all aware of the importance of client diversity. So yeah, we wanted to use minority clients today. So yeah, a little bit more into like the validation process. It's basically what it keeps Ethereum secure, you know? And staking on Ethereum can take many views, but let's take like the more canonical like idea of what staking is. Definitely a lot of changes going on in this industry, yeah. But okay, canonically, what it means to stake is to secure the Ethereum network by making a deposit, which has like a transaction of a financial bond, which is 32 ETH that you have to like deposit into like what is called the deposit contract of Ethereum. And the idea there is that if you validate transactions honestly, then you get like a certain payment. And if you are dishonest, then you basically can lose this bond. Because Ethereum does not have like a native delegation model, then you either go through like running your full node, or you could have like a few options. For example, like the most decentralized of the liquid staking solutions are probably better. And yeah, maybe other options that we don't want to encourage, okay? So, and yeah, going a little bit further into like those rewards and slashing conditions. Basically, here I just want to quickly mention like the incentives and like the design solutions that the protocol has had, but like very quickly. So in the same sense that you have like an execution layer and a consensus layer, then you also have like execution rewards and consensus rewards. So the consensus rewards make like the biggest like piece of the pie of the rewards at Ethereum. And they basically come from like doing like the attestations and proposing the blocks. Attestation means voting inside the system, okay? Voting for the different blocks and voting for them to be included. And very rarely then producing blocks. I mean, you probably will be producing blocks, but it is kind of more random than doing like the attestations. And in the same way that you can earn those rewards, then the exact amount that you earn is what is detracted from like your balance when you are offline, for example, or you fall into like what is called the inactivity leak. And that isn't like really slashing. Slashing is a completely different thing. Hopefully today we'll have enough people to like try that and see if we can get a slash in our testnet, just to see how it is. But yeah, and slashing can go like from like 1 ETH to losing like the complete bond, so the 32 ETH of that you have in your balance. And yes, finally, okay, you have a question. Yeah, exactly. Basically, this penalty that you can get usually comes from being online, and it is the exact amount that you would have earned in the same period, like you said. And like you said, slashing comes from things that directly attack like the consensus of Ethereum. So that is usually like either double signing, putting like the same keys on 2 different machines is very common. If you like forget, I don't know, probably shouldn't, it's money after all. And also like basically trying to do like surround voting, which is difficult to explain, but basically you're trying to change like the canonical change back, like the historical data that has already been added to the blockchain in the future. But yeah, I can explain later if you want. And yeah, I guess that the last thing I wanted to mention, because it's very important for what we're going to do, is, yeah, you can pass that. I think we talked about it. Keys and signatures. So today we'll be actually going through like the process of generating keys and everything here in front of you. And keys and signatures are like the main cryptographic like primitives that allow all the communication that is going on in the network. When you look at the most like base level, you can definitely look into like the different block explorers, and you see like all the different keys that are interacting with each other, all the contracts which also have like these different signatures and everything. And yeah, hopefully we have the time to look that in the block explorer. And they work through something called hashing, which is basically a cryptographic term, and it's more like a more efficient way to like securely store data inside of the blockchain, which is like the entire basis of the protocol, I think. And basically you have like this digital signature that represents like the validator, and you get it from like a key generation algorithm that we'll go through in here, like I said. And there's also like a signing algorithm and a verification algorithm that go behind like the scenes to really verify that everything that is getting added is well correct. Hopefully we have like the time to see all of those things. And yeah, I hope this wasn't very boring to you. Like I think this may bird's eye view on what the protocol is. It's important to like understand what we'll be seeing. So yeah, I think it's time for the demo.
Nice. Okay. Then I'll take over. And I will just work from this GitHub repo that you can try and find. So basically, the way I kind of thought might be helpful for you is like I'm going to walk through the demo. I would kind of like recommend you kind of then in the self-study time retrace my steps. You can just do the same, and then yeah, go on. The Wi-Fi, I think it's best to connect to the Devcon workshop one.
Yeah, I think so. It's not working. It's working for you? Okay. Are you guys okay with the internet, you think? You're good? Okay.
It's working on mine. Worst case, you can borrow my laptop. Cool. Yeah. All right. Not my NFTs. Yeah, okay, what was I saying? Yes, I'm going to walk through a demo. I think it would be best if you then kind of like retrace my steps. And then there's kind of some exercises. Like first we're going to do try the Lighthouse client, then you can try the Techo client yourself. And then number 3 is like fairly challenging, but obviously if you're feeling adventurous, you can walk through these steps too. And then I think we'll kind of like reconvene and then see what people are interested in. Either we like exit our validators or we I don't know, explore the block. But let's get into it. Go on. Okay, actually, let me just kind of like describe the test, the steps. That's a brilliant question, actually. So generally, on a higher level, like what you need to actually like become a validator on Ethereum is you need to generate your keys. That's like step 1. You need to set up your infrastructure, and then like make a deposit of like 32 ETH. We're going to use test ETH, by the way. And then it takes a while for the validator to be activated. And because of kind of like we have to take a shortcut because also like girly ETH is like pretty sparse. And also like this like waiting for the validator to be active, I don't think it would be feasible in this workshop. So basically what I've done is I already generated keys for a testnet. And we do have like some of the infrastructure already kind of like set up. We have like an execution client and a beacon node, which is already synced, provided by Chorus 1. And basically we will set up the validator client and connect to that. And this will be on testnet. So no like private net. Any more questions before I jump into the demo? Thanks so much. There's like a, seems like it's a market, it's a real market. Yeah, cool, we can do an auction later. All right, let me sit down. Got this weird setup because my screen is broken, but this works actually really, really well. All right, let's start. Yeah, steps. Step number 1, what we want to do, we want to generate our keys. And the way I do this, actually, if you go into the repo, you want to open this link, which takes you to the staking deposit CLI. It's an open source project by the Ethereum Foundation. When you open the link, just download the CLI for your operating system. Probably best if you just, I've already downloaded it, so you don't need to watch me do that. So basically what the deposit CLI will generate, like 2 important artifacts. Number 1 is the information, it's called the deposit data, the information I need to make my deposit. And number 2, actually probably the most important, it's going to generate your private signing key. So as like Gabriela was saying before, whenever a validator like basically makes any attestations or like proposes a block, they need to sign it. They need to sign them so they can be held accountable. So is there anything else I want to say there? No. I'm just going to like run the CLI to show you how this works. There's this command called new mnemonic, which will like generate a mnemonic for you. Anyone wants to know what a mnemonic is? Or is everyone aware? Basically, a mnemonic is like a list of words you will see in a bit, because it will generate it for me, which represent the seed. And from this kind of like seed, I can generate my private keys. And the cool thing about this is that it's like deterministic. So the same mnemonic will always generate the same key. So in case you lose your key, you need your mnemonic to regenerate them. Okay, the CLI is asking me a few questions. I'm going to pick English. I want to run one validator. Oh, yeah, of course. Does that work? Cool. This is an important bit. We're gonna do this for girly testnet. Yeah. And then what the deposit CLI will do is, as I said, like generates my private signing key, and it will decrypt it. And the file is kind of like called a key store file. So here, in this point, I'm gonna select a password, which I can then use to like encrypt my private signing key. I'm gonna type it in again. Yeah, this is my mnemonic. That's the thing I was talking about. Need to copy it and put it somewhere. Don't show it to anyone. And this, oh cool, it's quite fast. So now it should have generated my keys in here. Let's have a look. The first thing is the deposit data. As I said, like this is the information we need to activate our validator. Because when I generate my keys, no one knows that my keys exist, right? So actually, I need to submit this information to the beacon chain and tell it, like, hey, this is my information. I want to become a validator, basically. But I will go into this in the next step. I just wanted to show you what is generated here. Actually, let's look into the key store file. So this is my encrypted private signing key. It looks a bit scary, but actually if we decrypt it with the password that I've typed in before, it would just be like classic private key, not scary looking at all. So yay, we generated our keys. Really like important things just to remember. Actually, the most important, if you remember anything from this section, like this is the private signing key, and we're going to use it later to start our validator client. Go on.
Okay. They use the same hashing algorithm, and yeah, the keys and the accounts basically look the same. Like if we look at the Explorer, you could see like they all start with like OX, and because they use like the same hashing algorithm, basically, yeah.
So would that be capable? Would that be the same thing as a wallet account? Like, you know, like, could I use this system and use that because?
No, because they're different like entities inside Ethereum. Like a wallet is recognized as like an account, and this is recognized as like a key, okay?
That's one, thanks. Where were we? Testing. Oh yeah, there it is. Any more questions? Because I'm going to jump into the next step. Because now that we have our keys, the next thing I want to do is make a deposit. Also, oh yeah, I've added lots of reading material, so you can depth first search your way into the demo. If you want to make a deposit, the best thing to do is go to this staking launchpad, and you're gonna walk. It's gonna take you through kind of some questions. I'm not gonna do it all in front of you. But it's actually, if you want to click through this, it actually gives a really good information, about deposit, about uptime, and general information. And once you get to the end of this checklist, it will ask you to upload the JSON file that we saw earlier, namely the deposit data. And then you connect with your wallet, and if you're super lucky, you have 32 ETH, and then you can just make the deposit. Girly. It's quite important, actually, to use the correct network. Okay, actually, this is pretty neat graph I found on the Prism documentation. So again, as I said, when we generate keys, no one really knows about them, so we have to make a deposit. Then kind of the validator comes into this deposited state, and in the end, it joins a queue. This is actually by design. I can talk about this probably later on. But then the most important thing is like it joins a queue and it takes a while to become active. And then as Gabriela already said, like if your validator like participating in consensus and everything's going great, you're getting rewards. But it could also be that like your validator, I don't know, like you like make a mistake, validator misbehaves, and then you would get slashed. And it could even get to a point where you get forcefully exited from the network. Also, like if your validator has been like 9 days active, then you can also voluntarily exit your validator, although there's no turning back. If you exit your validator, it's done. And at some point, after the Shanghai fork, we will also be able to finally withdraw our ETH. Okay, I think that's everything I wanted to say here. So we generated our keys, we made a deposit, and now we're actually ready to set up our infrastructure. Go on. No, it's fine.
Can you repeat it? Sorry.
No, because we're doing the stage to become a validator, right? So, like, how do you do that?
Okay, yeah, I see your point. Okay. I mean, in this workshop, I guess we are showing you how to run your own node, so you will be your own staker. We do have, or there exists like liquid staking solutions, because to run your own node, you would need like 32 ETH, which, yeah, it can be a limitation to some people. There are like other liquid staking solutions where they ask you either like a smaller bond, or you can do like just deposit the staking in a different protocol, deposit like, I don't know, 1 ETH, if that's everything, all that you have. And you get the staking rewards without having to run your own validator like at home, like the entire setup. And okay, yeah, then there's also other solutions. We have like this API that you can do these steps easier with. But yeah, I guess you can be a solo staker. You can stake with like a liquid staking solution or like a staking pool. Or yeah, stake with centralized entities.
Sweet. Gabriela actually gave like a really good overview before of like the infrastructure involved, and I just want to repeat that because I think it's like really, really important to note. So what we need is we need our execution client, which is responsible obviously for executing the consensus. We actually already have we will have a Bezo node set up, and then you also need the consensus client. And this kind of consists of 2 parts. It's like the beacon node, which connects to the P2P network, and then the validator client, which you're going to run locally, which actually manages which manages the validators. And again, here we had to take a shortcut because both the execution client and the beacon node, they actually take a while to sync. I know there's like workarounds, but I still thought it's like easiest. We already connect to an synced execution client, a Bezo node, and a synced beacon node. I believe that's a Teco node. Again, both provided by Chorus One. So I think the first thing we should do is just make sure that the beacon node, we can connect to it. That would actually be tragic if not, but let's have a look. I was trying it before. So that's okay. Seems fine. We can connect to it. I also included a link for the whole beacon node API. So if you're feeling like you want to explore what the beacon node looks like, you can actually again in the demo you see the URL from the beacon node that we provided, and you can just play around and send some requests if you fancy it. Okay, so. Summary, we have a beacon node synced, connected to an execution client already synced. So all we have to do is we pick a validator client. And the one I'm going to show in a demo right now is Lighthouse. So Lighthouse is a validator client written in Rust. They have really cool documentation. Actually, I think when I started looking into this, they were still fairly minority, so they really caught up. Yeah, okay. So we're gonna pick Lighthouse, and what you do is you pull the Docker container. Sorry. Okay, I can talk again. I've already like pulled the Docker image. So let me just try and see this if this works. Yeah. So you don't have to watch me download a Docker image. And once we have this set up, actually let me now jump into VS Code because it's going to be much easier, I think, to show you all this configuration. Okay, so I'm going to jump into demo and then Lighthouse config. And Lighthouse has like a neat thing, this validator definitions YAML, where you can configure all the validators you want to run in this client instance. And I'm just going to walk you through this. So you can actually like run multiple validators in one instance. And you can like, here's a flag to enable or disable. Here comes the voting public key. That would be from the key that we like generated. So here you basically want to say, okay, I'm running this validator, and this is how it will kind of identify you. Since the merge, we also like have to or want to configure a suggested like a fee recipient. Yeah, actually, let me go into this. So before proof of work, the miners would like receive some kind of tip in the transaction when you put them in a block. And now with now after the merge, actually these kind of tips go to the validators. So with the fee recipient, you just kind of like specify which address this should be sent to. I just put a burner address in there because if I don't, Lighthouse will like start complaining and logging some warnings. Yeah, and then actually most importantly here, we actually want to configure our keys now that we've generated before. There's other ways to configure them. Just for simplicity, we're going to go for a local key store. And then you just kind of show the voting key store path. So basically, remember the key store, our encrypted private signing key. This is where you point to. So you point Lighthouse to the path, and then you give it the decryption password because obviously it needs a signing key to like sign whatever attestations you make. So this is all the configuration. Just to show you here is my voting key store. And Lighthouse is, just want to mention this, Lighthouse is very opinionated about how you name kind of these folders and files. So if you run into errors, then it could also just be like, maybe you had like a typo in the name or something. But now I have, any questions on this? Yeah. So basically what I meant is like I could actually have like 2 or 3 validators just in this client instance running.
Yeah, I think it's important to say you have to have like one execution client connected to one beacon client, okay? But inside the beacon client, you could have several validators. It's like a one-to-one relationship between the beacon client and the execution client, but many validators, and it's fine.
Thank you. Not sure if I'm audible. Yeah? Yeah.
Yeah, any of those works, as long as you're having like a one-to-one relationship between the beacon and the execution part.
Thanks for mentioning that. That's
Yeah, it's actually important. Thanks.
Cool. Any more questions?
I mean, the idea there is to have like more of an opportunity, I guess, to earn like the rewards and propose more blocks. And I guess on the other side, like to keep like more secure the network, like the amount of validators is like a measure of security, I guess. Okay. Yeah, that is what I meant when I said that this is like the canonical way of running it. But there are a lot of things going on in like the staking like part of the world. Well, like she said, if you want to learn more about distributed validators, go ahead. We had several great talks about it here at Devcon.
Yeah, we actually had a conversation about it yesterday. So it didn't take too long for someone to bring up distributed validators. I like it. Okay, I mean, keep the questions coming. It's really important. So now, like, we finished the configuration of our Lighthouse client. We can actually jump into like running our Docker container. So basically, I need to do Docker run. I expose the port, and then I mount my configuration into the Docker image, so it's accessible within Docker. And then here, this command is fairly important, like validator client, because Lighthouse offers, it actually offers also to run the beacon node and the validator client in one process. But here, obviously, we want to kind of like split it up, run it separately, because we want to connect to a synced beacon node. Lighthouse also has this like argument in its slashing protection. So what it will do is it will kind of like set up a slashing protection database. What I have to point out, though, is that this only works within your client that you have running. So if you have like 2 Lighthouse clients running, then this slashing protection, this internal one, doesn't help you. We specify the network. We specify the beacon node that we want to connect to. And then I need just this validator steer argument to tell it, OK, this is where my configuration lives. So then, let me see, I'm pretty sure I've done this before. I'll just see if I have this command in my history so I don't have to type it all in. This looks good, actually, from my point of view. So I'm going to try and run this. And hope it works. OK, so what's interesting here in the logs? OK, yeah, we want to run this for Prata. That's really important. Oh, well, now it's going quick. This is my, it found an enabled validator in my configuration. This is the voting public key. We can quickly check if that's true. Yeah, exactly, this is the one we configured. What else is interesting? Yeah, this is really important. It connected to the beacon node. If the beacon node wasn't synced, then you would see this in here. It would tell you like the beacon node is out of sync. And now, yes, this is also very good news. So the validator that are running is known to the beacon chain. So that means we actually made the deposit already and it's active. Yay, and this is our validator running. Now, to show you kind of like a proof of this, we're going to go to beacon chain, probably like one of the very famous tools to kind of like analyze your validators. I'm going to copy paste my public key. And now, OK, now it shows me some information. Here you can actually see like the statuses I was talking about. So when we made the deposit, it was in the deposited state. Then when it was like queuing, it was like in a pending state, and now it's active. And the reason why it's red is because the key wasn't running anywhere. So I only just started the validator client with this key, and this is why it's leaking. So if you're like this is why validator uptime is so important, because if you don't ensure that your validator is like running, you will lose some of your deposit.
Yeah, I think you can show in like the attestations.
Yes, exactly.
You would see that we were missing attestations because we were offline.
Oh, look, it already attested.
Oh, we already attested once. Okay, since it started running. But yeah, you can see we had like a lot of missing attestations because we were offline. But yeah, cool. That worked out perfectly. We are attesting.
Is there anything else interesting we can show in here? Maybe? Can you?
I don't know. Yeah, question? Can you pass him the microphone, please?
Yeah, no, since you guys had asked anything interesting, so one thing that we I've been paying more attention to, I guess most validators probably will pay attention to it to some degree, is the effectiveness rating. I don't know if you guys have already talked about that, but that can affect the degree to which you receive like the full amount of a reward for attesting or producing a block. Just kind of measures how like the latency or how late you are in terms of being able to attest.
Yeah, that is like your ranking in the network. Yeah.
Yeah, I can't see what it is right now because I'm like kind of blind, but.
What is? Let me see.
It should be at the top.
Yeah. Effective.
Effectiveness rating.
Okay, yeah, I think it's 90%. No?
Is it this one? No.
No, 50.
This is active 32. Oh, that's weird.
Yeah, I actually don't see it. Why?
We can look for it. Maybe we'll find it.
Yeah, give us a minute and we'll find it. Yeah.
But I think this is like this kind of concludes the demo. If you want to kind of clone the repo. No, don't worry.
Absolutely, don't be sorry. Actually, this is what a workshop is for. Like, if you want to interrupt us, absolutely.
So I just want to understand, like, this attestation is like the validation of the station blocks, attesting new blocks, or other validators attesting that these validators are now alive.
Okay, yeah. Yeah, I guess I forgot to mention also something that is kind of important when I mentioned like the fourth choice rule when I went into that point. So basically what you're attesting to is the blocks. So you propose the block very rarely, but everyone should be attesting to like the blocks. Probably all the time. Like you would want to have like a 100% attestation rate. Like it's a little bit common now in proof of stake. It is like the analytics show that it is a little bit more common to miss attestations. But yeah, you should be attesting each block and voting. And the reason I mentioned like the fourth choice rule is because Ethereum has this rule of not like, for example, something like Bitcoin, which is like the longest chain, but it is the chain with the most weight. And the weight is measured in attestations. So for example, if you had like a different choice between like two forks, and one of them weights more, like has more attestations added, or yeah, they're like cryptographically added, I guess, then that is the chain that it would choose you.
Is there a way to withdraw the stake and rewards, or is that also locked till the Shanghai update?
Yeah, so like I mentioned, there's two kind of rewards, like the execution rewards, you get them in your wallet and you can withdraw them like immediately from the fee recipient address that you decide. So those comes from like the different like transactions. So the transactions that you add inside the block, they have like a tip and you get those tips. And also maybe something more complex like MEV, like that also goes into that. And then the consensus one are the ones that are locked and cannot be moved. And those are added to like the balance. So for example, you can see there, can you see? Yeah, the balance says like 32 point something ETH, but what you added, what you deposited is 32. So you already earned something there, but you cannot move it yet. And eventually when withdrawals are enabled, there will be like probably two options, like do like the full withdrawal. So like all of the basically ETH that you have, or like just a remain, like what is above 32, because you should always have like the 32, okay?
To specify, so the wallet address you entered earlier where you had it in the editor, That's the one where receive the...
You will receive the execution rewards
Alright.
there, yeah,
And,
and you
out
can
of
move
the
it.
frequency, how often they're paid out?
I mean, it really depends because it is like determined by when you propose a block, and that is basically random, so very hard to. I mean, you could like analytically say that, for example, you propose a block like once a year or something, but yeah, that would be like a curve. Like, yeah, you propose basically randomly chosen.
Thank you.
You're welcome. Okay, you. Okay, you first, and then you. Okay.
Okay.
Because you have the microphone.
Question. At one point, you said like you were mentioning the difference between like the beacon node and the validator client. You do need a validator client to like sync with the rest of the consensus B2B, right?
Yeah, the client needs to be connected to the beacon node, yeah. And this is what I actually configured when let me show the command again.
When you went to the YAML.
Yeah, no, actually when I started the Docker container, I had to specify the beacon node that I want to connect to. And if I can pull this up again, I can show you. And this is really important because if we don't have this, the validator client can't run. So it's actually this bit where I specify the beacon nodes, and otherwise you wouldn't be able to start.
But I mean, could you have like one beacon node and run like different validator clients inside it?
Yeah, you can connect multiple validator clients to one beacon node.
Okay.
Yeah, I think most clients allow for that, but yeah, definitely check the documentation. But I think most of them allow for a different beacon chain and a beacon validator client.
But, at this point, during this workshop, we didn't spin up the beacon node like you had it beforehand.
Exactly,
Gotcha.
Because it just takes a while to sync.
It takes
exactly,
a while. Yeah, gotcha. Okay,
Yeah.
thank you.
No worries.
So 2 points. I believe you were asking about syncing, right? So I think the execution client and the consensus client need to be synced, but like the validator client need to be connected,
Yeah.
right? Not synced.
Yeah.
Yeah. And the second thing, regarding attestation.
Sorry, and to add to that, yeah, they are synced because they are the parts that are actually connected to the peer-to-peer networks. So they have to sync to all the blocks. Just that.
Yeah. And regarding attestation, as to what I know, each validator need to attest once each epoch, right? Like each 32 slots.
Each slot, yeah.
Each 32 slots, the validator has to attest only once, right?
Each epoch, you say?
Yeah.
I think that they have these things called committees, and yeah, basically, yeah, to get a little bit more complicated, yeah, 128 validators are chosen each slot to attest, and these committees are like rotating, so they rotate between because it is already kind of hard to reach consensus in time with the amount of validators that exist. So there needs to be like other models to like aggregate the different signatures, and one of them is like the sync committees. That it is what she's mentioning. Yeah, you are right.
Hi, I just got a quick question.
Sure.
Quick question. Where's the execution client running? I mean, is it running together with the beacon node in this setup, or?
Yeah, like the execution client we have running somewhere. You wouldn't see it because like the beacon node is connected to this execution client, and the beacon node is basically what we make available here. Yeah.
Okay, it is running on Chorus One.
Yes, exactly. Chorus One infrastructure.
Thank you.
I think you can show him the picture in the slide, so they can have like the full look at the architecture
This
of
one,
a
right?
node. That is what a node looks like, okay? Like a full node. You have the beacon node, the execution engine, they connect, they talk to each other.
So we have both of them currently running on Chorus infrastructure, and we just connect to the beacon node with the validator client.
Is it recommended to run the same node on the same computer?
You would be then talking about things like latency. For example, if they are like two separate, you could fall into a situation where they don't communicate in time, So when you are like trying to, I don't know, propose a block and you go into the consensus, you missed a slot. It definitely would depend on like the capabilities of your machine to do so. But yeah, you definitely have to like take into consideration like things like latency and the capabilities.
I think actually also one point, let me go back to this, how to run this Docker command. You can actually connect to multiple beacon nodes. And this is sometimes recommended just to have some kind of like failover to make sure you're like connected, definitely connected to a beacon node. That was nice. That was like really nice questions. Yeah, thank you. What were we gonna do? I think so. Yeah, actually. Oh, maybe one point that might trigger some conversation. Maybe like having walked through this demo, maybe you're noticing some kind of like limitations with this like setup. A few of them kind of I think are obvious. Like we had we like configured the local key storage can be maybe a bit dangerous if you just have like your key stored locally with the decryption password. What you could do to kind of like improve this, you could actually store them in Vault. In that case, they're also usually backed up. Also, because we're just running like one validator client, we are really dependent on the Lighthouse software. And this is exactly what Gabriela showed before. We saw this actually with Prism like a few months ago. Like they had like a lot of validator clients where like Prism was kind of like represented. And the problem is just like if there is really like a bug in the software, it can become really tragic for Ethereum, for the network, because it could be that like the chain can't finalize. And this is why client diversity is so important. Just so if there's any errors, the network can survive. And then something you can explore in the exercises is I already talked about the slashing protection that Lighthouse has. If you're actually running like multiple instances or multiple clients, this won't serve you. So there's one exercise. If you're feeling adventurous, you can actually use a remote signer. And if you have like multiple clients, you connect the remote signer. That would also enable like slashing protection. Yeah.
You just mentioned the key management part. If you could elaborate a little bit on like what you see people actually do with their keys, and like the good and the bad. And then the second part is, from what I understood, is basically these two JSON files. It's all what you need in case your computer that you're running a node will be stolen or burns down or whatever. So it's really, as long as you have those two files, the hardware doesn't really matter. Is that correct?
You mean like the deposit data and the key store JSON, right?
Yeah, these two JSON files.
So the deposit data, essentially, you just basically need it kind of like to make the deposit. And the keys, as long as you have your mnemonic, you can regenerate them. That's true. So if your like hardware is broken, then keep your mnemonic, and you can regenerate from there.
And then spin up the node again, because
exactly,
as long as it's offline, you can spin it up again,
yeah.
And then you should be good.
Exactly. Yeah.
Okay.
Yeah. And on your first question, one of the things that I guess it's not an issue, but it is important to note, is that you always need to have like your private key online. So you cannot have it like offline, like stored securely in like a vault. You need to keep it like online so that they actually the network can connect and you can actually sign. But like she said, there's these solutions like the remote signer and other like different kinds of solutions where you can have it like remotely or stored somewhere, or there are like a lot of things you can do in terms of like key management, and it is definitely important. I mean, I've known of people who have like their key freely on their computer, like just signing like that. And yeah, it's definitely like a security risk, even if you do have to keep it online at all times.
Okay, thanks again so much for the questions. Go on.
So, piggybacking on what you were just saying about best key practices, like is this, where could we do you recommend any sources where we could read more about this and like those best practices, security?
I'll find those out for you and send them.
Okay,
Yeah.
thank you.
There's one section here which goes into remote signers.
Yep.
And if you open this up, one example that I give is Web3 Signer, which is fairly it's kind of a famous product actually. So if you go into this link, there's also good documentation because with this remote signer, I don't want to go too much into it because you can read through this now. But there you can, I think it supports storing your keys on either HSM or in the vault or locally.
Okay. And let's say that for some reason those keys were compromised. Is there anything I can do or I got wrecked?
What do you mean compromise?
Compromised as in someone...
You gave them to someone, please don't.
No, I connected my laptop to the HDMI of the New York Times Square screen.
You connected the same computer where you're storing your keys on the... No, please don't.
Let's say, I don't know, everyone in Devcon had those keys. They are completely compromised.
Yeah,
What
I mean,
can
if they're
do?
compromised, I'm sorry, you just got wrecked, yeah.
Okay.
Sorry.
And last question was, now that we went through all of these, this is the manual setup, right? Let's say I have my own hardware, I set this up myself. What are the pros and cons versus using something like Ethereum or Dapnode or any other simple UI, let's say?
I mean, yeah, those solutions are pretty cool. They already come with the pre-installed software, so you don't actually have to do anything of these that I've just shown you. And yeah, I personally think that they are good solutions for first-time stakers or anything. But yeah, I think you get a lot more customization through your setup by doing it yourself and configuring everything. And yeah, that gives you a lot more flexibility into what you can do with the node.
Also, I mean, the purpose of this is really to share the knowledge because this trend, I think this trend is good to make sure a lot of people can run nodes, but they also oversimplify, which can also be a bit dangerous. So I think it's definitely worth learning, worth understanding the underlying kind of infrastructure. And with this, if more people actually customize their setup, then we would have more diversity. Because why we end up with no diversity is because everyone runs the same product and they run the same nodes. Yeah.
I would say on the key management stuff, at Coinbase, what we would do is we would import the key into an in-memory embedded database, so that way you don't have to have it you don't have to store it on your disk. So you could import it from a vault, I don't know, HashiCorp or something like that. If you set up the remote signer with Web3 stuff that Consensus has, you need to set up a Postgres database. One of the ways that they manage risk around key, let's say you lose your key, what they would do is we have pre-signed messages with the ability to exit. So if things got compromised, you would have a pre-signed message that you can just submit to the smart contract to exit. So you could also take that approach.
Yeah, that is a good approach. I think it's always a good thing to have a database when you store what is happening with your node. Yeah.
So I think these are the signer keys, right? That is separate from the withdrawal key.
Correct. Yeah.
So the risk that he would have if his keys were compromised is someone double signing and then at risk at being slashed. Okay, that part I have correct.
Yeah.
What would the withdrawal? I know it's not available yet.
Yeah.
But what would the withdrawal process look like? when we're ready to withdraw some of our
That's
30
an
keys?
excellent question.
I mean, that is to be specified by the Ethereum Foundation, and yeah, they did like this whole discussion, I think it was day 1 or day 2, where they went into like the different possibilities for specifying that, but yeah, that spec is not ready yet.
Waiting. Any more questions? Honestly, I'm really enjoying this. It's been really nice conversations. I guess the idea, like if you go to the repo and you unzip these key stores, we have like 16 keys pre-generated, already deposited and active. I would say you just choose randomly which one you like, and then if we're really lucky, maybe we get slashed. I think it would be like that. The worst thing that could happen is that we get like slashed heavily because you're using. Probably people will use the same keys. But I think that would be quite exciting to explore, actually.
And you'll have these, right? Like, you'll have access to it?
Everyone has access to the repo. Then, again, unzip the key stores, and you can pick one of them, which you can run. You can run a demo and just continue. If you have any questions, just give me a shout. Happy to help.
I think, okay, you have a question. Okay, yeah. But this is like the time for you to like do what we just show you and see what happens. Like anything could happen right now. Yeah.
So you didn't cover it specifically, but you mentioned you showed the like set up your own validator demo site that they have set up.
Mm-hmm.
I was going through that, and everything was going fine, and then I saw that they wanted me to like do port routing on my home router, which was like opening ports on my computer to the general internet, and that freaked me out. I wasn't comfortable with that. Is that necessary to be a validator?
Why did you say was that? Sorry.
In the not yours, but the like how to set up your own validator website.
And this staking launchpad. You mean when you clicked through it? Yeah.
So in that, one of the steps is to go into your like home router and open ports on your computer to the general internet. And
is it? So the only way, is it somewhere here? The only way where this kind of like would make sense is like for the beacon nodes to sync. Because usually what they do is, I mean, either like you configure it that you have like checkpoints, but usually they like really like try to like find other like nodes to kind of experiment.
Makes it easier for them to find more peers?
Yeah.
Okay.
I'd say so.
Okay, but it is not so there it is, the third check. I forwarded the necessary ports to the correct machines. So I guess, yeah. So it's not necessary to become a validator. It just makes it easier to find peers?
I mean, to be honest, like now I'm not so confident
No,
anymore.
I think that means like opening the ports for like the connection between the EL and the CL, like between themselves. Does it say like connecting to the internet?
Yeah.
I don't see it.
Okay, so if I'm running my EL and CL on the same computer, then that is not necessary.
That would make sense because then you don't have to open a port, right?
Right.
Yeah, that makes sense. Yeah.
Okay, only for.
Okay, him.
Oh, can you answer the question?
Yeah, okay. He has the answer. Let's see.
Yeah, so it's not technically necessary, but we've run many different types of nodes over the years, and you will fall behind in synchronization.
Yeah.
So it's meant for simply that the peer-to-peer network works. You need lots and lots of connections, and if you don't have any incoming port, it means you will have outgoing connections that will bootstrap, and you will sync the chain at some point, but the incoming connection pools is like a scarce resource on the network, and the longer you stay online, you sometimes get blacklisted by other nodes, and there are many different things that can happen. So usually what happens is that you see like you have start with 8 connections, and then it goes down, 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 and you have 1, and then you have maybe 0, then it tries to bootstrap again, and then you fall behind, and then you will miss some attestation. So it will perform worse. I don't think it's that critical. I think the most yeah, the 30303, that is the most important one to have opened. Because that is the majority of the data that needs to get pushed through. The other ones, the 9000, is sort of less. I'm not sure. I always open both, but I think the 30303 is the most important one.
Good
yeah,
answer.
so like
Yeah.
expanding
Thanks so
on
much.
that, like that's exactly right. Those peer-to-peer ports are necessary for finding other beacons to communicate to.
Yeah.
You need those to broadcast your messages, and then also like to sync as well. And the way that like communication happens through your clients is like it's going to reject something that doesn't match the spec. So like even Coinbase has those ports open. So like you should feel comfortable having them exposed.
Yeah. I get your concern, but yeah, I think
Maybe
that-
let's start talking about network configuration. If you are in a hosted environment,
Okay.
what you absolutely must do is set up a local firewall for outgoing connections, okay? Because if you are in any sort of Hetzner or AWS or other environment that monitors for network attacks, you will get your service contract cancelled if you just leave it open like that, because in the payload of the peer-to-peer network, people are injecting weird stuff like not assigned IP addresses and so on. Your node will try to connect to those, and that will be seen as an attack. And actually, I had to do that multiple times to restore my service contract with them. So.
This guy runs nodes. Yeah.
That's why I invited him to the talk, in case I couldn't answer any questions. Thanks so much. Sweet.
So to continue
One
what
second, yeah.
was being said about the ports, I'm actually a Lighthouse developer, and I handle networking. So the thing is that when you start your node, you connect to some peers, but on time, you're going to be dropped because they're going to prefer some other peers, or I don't know, maybe they're going offline, doesn't matter. You need incoming connections. And since in networking, we are forwarding, let's say like information about one peer to other peers so that they can connect between themselves, it's likely that your information, if you don't have ports open, it's not going to be forwarded to other peers. And even if it is because, I don't know, maybe it's wrong, and you are claiming to be reachable from the outside, they're going to try to reach you, and it's going to fail. So yeah, it actually makes you vulnerable to attacks, not having ports open in that way, because you need to have peer diversity.
Exactly.
Thanks a lot.
Thanks.
Nice to see a Lighthouse developer.
Yeah. Cool. Who's trying? Like, who is doing it to see? You.
Nice.
Are you guys trying?
Sweet.
Do you find it difficult, or what is going on? Or
Wait, we have
you
a-
just
we
don't
have
want
a
to?
question.
Okay, we have a question. Sorry.
Is there some place, I know for the shortcut, you didn't show how to do the execution client and the
Hi.
beacon node.
Mhm.
Is there some place where I could see that part of the process? Like, did you make a video of it by chance? Or
Like how we set up the execution client.
Yeah, I would like to see that.
No,
No?
sorry.
No?
No.
Layer clients, they have documentation on how to go through the entire flow of setting up the execution layer, as well as the consensus layer client. So, I mean, in case
Yeah.
you're trying to find a reference.
Lots of
also, like Coin
documentation.
Cashew, there's a bunch of resources on.
Well,
So you wanted some more information about slashing, is that?
I understood that when two validators in different computers are together and in the same network, they get slashed. But what else can arrive in a slashing?
the two main things that, well, the two really big rules that you have to follow are no, like you said, double signing. So if you have like these keys running on a certain infrastructure, make sure to exit that infrastructure before you decide to deploy it somewhere else. And the second one is called surrounded voting. And this is like an attack tactic towards like trying to change like the historical data in Ethereum, basically trying to change the past of the network. Yeah. And those are regarded as like attacks on the consensus, like they affect that part. So that is why they are like regarded as slashing conditions. I mean, you can have that. You can set up like do we have like a database for like?
Yeah, the slashing database basically kind of like records who's currently proposing. And also like with this Web3 sign-up product, if you have like multiple instances of it running, it would usually like connect to like one kind of like global database. And by database locking, it will always kind of like update like who's currently signing which attestations to avoid double signing. So like if one key is like currently like doing something, then a second key, like actually the same key running somewhere else can't access it. Sorry? A small? No. I mean, I guess, yeah. I mean, it's like, this is like how you like, record the state and make sure like, kind of like lock someone else's to like make sure that you have like a concurrent process.
Yeah, so we've mostly pretty much 100% tested and operated with running the same client type for both the beacon and the validator node. Have you guys tested running like a Prism validator against like a Lighthouse beacon node? Those different combinations. I know the EF Foundation, they test different combinations, but mainly between the execution layer clients and the consensus layer clients, not between the two execution layer client components.
Yeah, like yeah, we totally tested that. I think we still I've heard from a few clients like still preference to like kind of like Lighthouse beacon node with Lighthouse client. Sometimes we like just to ensure kind of like uptime, you want to configure multiple beacon nodes, and there like you have the option. Like generally, like so far it's worked fine. Actually, I think I'm pretty sure that this beacon node is a Teco beacon node, and we just connected to it with a Lighthouse client. So that's one test we ran just now.
To the ones that are trying, if you go into any errors or you find something cool to show, definitely share.
Maybe now it's time to start some elevator music, some launch background.
So they play music at some of these things. Yeah, like this, exactly. Awesome.
Amazing.
And to everyone, thanks a lot for coming. I hope this was like really informative. We definitely want to, promote everyone that if it's possible to run a node. You don't even have to run like a validator node. You can also run like just a full node that does not validate, and those just keep like the consensus going. So yeah, I think that is possible even if you don't have like the 32 yet. So yeah.
Thanks.
And you can still stay here if you're working, and we'll also stay here until like the designated time. If not, then thank you for coming again.
Yeah. course. I can come to you, it's fine. Oh, really? Oh, okay. Which,
So I use WSL. I don't know if that is a problem.
you know, I think it should work. Let's have a look.
I already downloaded the file.
Yeah.
I'm trying to unzip
And that's the correct, but